Here we'll do extra practice on nonlinear systems. Our system says we have x squared plus 4y squared equals 8 and 3x squared minus y squared equals 11. We're going to try to find the solutions for this system. We'll need to decide whether we intend to do this by substitution or elimination method. Either one of them will work though. I'll run through this problem with the substitution method and then show you how it would be done by elimination. To solve by the substitution method, we'll begin by solving for one of the letters that's the easiest to solve for. Since all of the letters are squared, we'll allow them to stay squared when we solve for them. So our first step will be to solve for one of the letters squared. Let's look for the one that's easiest to solve for. We'll look for a letter that's by itself and has no coefficient. The best candidate for this is going to be the x squared in the first line. With this in mind, we can say x squared plus 4y squared equals 8. And if we're going to try to solve for x squared, let's just subtract the 4y squared over to the other side. If we solve, we'll end up with x squared equals 8 minus 4y squared. This will allow us to now replace the x squared in line 2 with this new binomial, x minus 4y squared. Let's remind ourselves that since this is a binomial, we'll replace x squared with the parentheses. Inside that parentheses, we're going to put that binomial. Therefore, our new line 2 will be 3 now times that binomial, 8 minus 4y squared. We'll now subtract y squared and set that equal to 11. I'm going to need to distribute this 3 across this binomial. 3 times 8 gives 24, and 3 times negative 4y squared gives negative 12y squared. We then have an additional minus y squared equals 11. When I combine my like terms, I can place the negative 12y squared minus another y squared. Remember your invisible 1. Negative 12 minus 1 will be negative 13y squared. We'll now have 24 minus 13y squared equals 11. To get the y squared by itself, I'm going to need to move the 24 to the other side, so I subtract. If I do that subtraction, I now have negative 13y squared by itself on the left, and 11 minus 24 gives negative 13. Then I may divide both sides by negative 13. When I do that division, I'll end up with y squared equals 1. To solve for y, I now take the square root on both sides. Remember that when you take the square root with a number on the right side, you'll get plus or minus. This means we'll have two solutions to this equation. We'll have y equals positive 1 and y equals negative 1. These are both valid solutions for y. With these solutions for y, we will now substitute those y's back into our system of equations to try to get the x's that go with them. I've copied the system of equations, as well as the possible y values we found, and the extra equation we wrote when we solved for x squared. Using the values of y we found in the previous page, and this equation for x squared that says x squared equals 8 minus 4y squared, let's place our y's back into this equation and see what x's we get. We'll now let y equal negative 1, and we'll use the equation x squared equals 8 minus 4y squared. We'll now replace that y with a negative 1. If we do that, we'll have x squared equals 8 minus 4 times negative 1 squared. Negative 1 squared will give us positive 1, and then negative 4 times 1 will give us negative 4. So x squared equals 8 minus 4, therefore x squared equals 4. And to get x by itself, we now take the square root. When we take this square root, we'll get two possible values for x. Because if you take the square root of a number that's on the right side, and we have x squared on the left, we get two answers, and that's going to be plus or minus 2. We can now say x will be negative 2, and x could be positive 2. Since our y was negative 1, and our x could be negative 2 or positive 2, we now have two complete solutions. We can say our first solution is negative 2, comma negative 1, and our next solution is 2, comma negative 1, remembering that x always comes first, y always comes second. We can repeat this process for y equals positive 1, which was our other y solution. Once again, we'll say x squared is equal to 8 minus 4y squared, and we replace that y with a 1. We'll now have x squared equals 8 minus 4 times 1. If we do that math, we'll end up with x squared equals 4, and when we take the square root on both sides, we'll end up with x equals plus or minus 2 again. This means our possible x values here are also negative 2 and positive 2. Therefore, we'll have two more solutions. Our x could be negative 2 or positive 2, and now our y is positive 1. This means this equation system has 4 solutions. So when you write the answer for this system, you'll write all 4 of these coordinates. We can solve this problem with the elimination method as well. To solve this with the elimination method, let's first look to the y squared terms. In order to use the elimination method, we want these to be equal but opposite signs. In the first line we have positive 4, and in the second line we have negative 1, keeping in mind the invisible 1 in front of the y squared. To modify this system, we're going to multiply line 2 by 4. You might notice if I multiply the entire line 2 by 4, that negative 1 next to y squared times 4 would give me negative 4, and negative 4 would cancel out the positive 4 in line 1. If I do that multiplication, my first line does not change yet, but the second line will change because we'll take 3x squared times 4 to get 12x squared, negative 1y squared times 4 to get negative 4y squared, and 11 times 4 to make 44. Now the 4y squared plus negative 4y squared will cancel out when I combine these two equations together. If I also combine the x squared plus 12x squared, we'll put that invisible 1 in front of x squared to get 13x squared. Then we'll have 8 plus 44 will give us 52. If I want to get x by itself, I'll divide both sides by 13. And we get x squared is equal to 52 over 13, which is 4. Then I can take the square root on both sides. When I take the square root, my possible x values will be plus or minus 2. So x could equal negative 2, or x could equal 2. Now that I know both of those x values, I can substitute either one of them into the system of equations in order to get y. We'll do that on the next page. Since I know x, my goal will be to get y. And so what we'll do is try to solve for y in one of the lines of the system. In this case, it won't make very much difference which one you pick because both of these y terms have coefficients in front, so it's going to take a couple steps of algebra to solve for either one of them. I'm going to use line 2 just arbitrarily for this example. We're going to try to get y squared by itself. I'll begin by rewriting this equation and say 3x squared minus y squared equals 11. Now I'm going to add y squared to both sides, and this will cancel out the y squared on the left. This gives me 3x squared equals 11 plus y squared. But then I'm going to subtract 11 from both sides. Now that gives me y squared by itself and 3x squared minus 11 on the left. With this new equation for y squared, I will now substitute my x into this 3x squared minus 11. We'll begin by letting x equal negative 2. We'll take 3 times negative 2 squared minus 11. We'll say that's equal to y squared. If we take negative 2 squared, this will give us 4. And if we take 4 times 3, this will give us 12. So y squared equals 12 minus 11, which equals 1. If y squared equals 1, we can now take the square root of both sides. This will give us y equals plus or minus 1. Therefore, we'll say that y could be negative 1 or y could be 1. Now that we know our x is negative 2 and our y could be negative 1 or positive 1, let's combine these together to make two coordinates. Our first coordinate will have an x of negative 2 and a y of negative 1. Our other coordinate will still have an x of negative 2 and a y of positive 1. These will be our first two solutions. Now that we've tried x equals negative 2, we'll use the other solution, x is positive 2, on the next page. On this next page, we'll now let x equal positive 2. We'll still say that y squared is equal to 3x squared minus 11. We'll place a 2 in place of x, so we'll now have 3 times 2 squared minus 11 is still equal to y squared. 2 squared is 4, times 3 gives 12, and so we'll have 12 minus 11 equals y squared. Now we'll take the root on both sides. We'll now have y equals the square root of 1, which is plus or minus 1. This means our y solutions will be negative 1 and positive 1. With that in mind, we can add to our list of solutions. Our x will be 2 with a y of negative 1, and with an x still of 2, our other y is positive 1. This still gives us the 4 same solutions we got with the substitution method. I've done this example to show that elimination will give you the same solutions as substitution if it's done properly.